Okay, we talked about adding, subtracting, multiplying, and dividing functions. Now this is another function operation, and this is a little bit more useful in a lot of ways, and this is called composite functions. And composite function is written in this form, FOG, F-O-G, you can see over here, F-O-G of x, or GOF, G-O-F of x. Oops, I need to put parentheses around the x's here. And I don't really like this notation because it really doesn't make a lot of sense to me, but really what it means is it means f of g of x. So if we see FOG, this one goes on the outside, and this is the inside function. So outside function, inside function, f of g of x, and GOF means this is the outside function, and this is the inside function, g of f of x. Now what does that mean? Well, I'll show you some examples. We use the same functions that we used in the addition, subtraction, multiplication, division examples. If f of x is x plus 1, that means f of something means that's something plus 1. That's the rule. This is the f rule. And the g rule is x squared plus x. So g of something means that's something squared plus something. So let's take a look at FOG first. F circle g of x. So that would mean, and I would always write this like f of g of x. And then I look at my g of x function, and that says whatever x is, so this is going to be x. Whatever x is, that means x squared plus x. So I'm going to write this as f of, and the g rule is, changes x to x squared plus x. Now what's the f rule say? Well, the f rule says whatever's in here, add 1. So that's just going to be, so I'll write it like over here, plus 1. And what was in here? X squared plus x. So it's just going to be x squared plus x plus 1. And then I can remove the parentheses, and this is what it is. X squared plus x plus 1, and that is f of g of x, or FOG. All right? So that's all there is to it. And that's the same thing. F of g of x is FOG. Okay, let's do the other one. G of f of x. So you see how that works. It's not too hard once you just have to be very careful. G, or GOF, as they sometimes say, GOF. G of f of x is that equals, so again, I don't like this notation, so this is the outside function because it's farther away from the x, and the inside function is closer. So it's easier to see, it's going to be something like that. So it's going to be g of f of x so that's going to be g of, and what does f do? Well, the f function says whatever's in here, it's just going to be x plus 1, so I'll just rewrite this as x plus 1. Now, what does the g function do? Well, if I look over the g function, it said something squared plus that something. So I could write it like this. Something squared plus that something, you see. But what's that something going to be? It's going to be the x plus 1. So that goes inside. Now I can multiply this out. I can have to kind of FOIL this. This is x plus 1 times x plus 1. Now don't say x squared plus 1 because we have to FOIL it out. In other words, this is the same thing as x plus 1 times x plus 1. That's x plus 1 squared, excuse me. Right? And then if we FOIL it out, first term times first term, x squared. Outside terms plus x inside terms plus x last terms plus 1. And x plus x is 2x, so we have x squared plus 2x plus 1. So remember, when in doubt, write it out. X plus 1 squared means x plus 1 times x plus 1. So this is going to be equal to x squared plus 2x plus 1. And then plus over here, x plus 1. So I can simplify those, and that's going to be x squared. And then 2x plus 1x is 3x. And 1 plus 1 is 2. So I could say that g of f of x, which is Goff, equals x squared plus 3x plus 2. That's that. So that's a composite function. So again, this is g of f of x, or Goff. And up here, this is f of g of x, or Fog. Okay? And they can follow the same order, so hopefully that makes sense. All right? So those are composite functions. So you want to be very familiar with those because those are very important.